Alright, good morning, welcome to
SuperMath number 16.
SuperMath 16. I didn't check. Are we sure this is 16?
I don't think so.
No, it's alright. We'll get it right. This is a problem from your homework yesterday that you had a little bit of trouble with. We went over it last night, but I thought it'd be interesting for you to kind of reason through it this morning and see if you remember how it went or sort of how that proof works. So we have in triangle ABC, AB is AC. What is that? What kind of triangle is that?
It's an isosceles triangle.
And M is the midpoint of BC. So there's a line from A down to BC, or a line segment, that chops this in half. This is midpoint. This line is called the median, but we'll talk about that another time. First, show that AM bisects angle BAC. So that means that this line segment makes these two angles here, BAM and CAM, equal. Why don't you go ahead and talk about that?
Well, this line, since it bisects this BC,
yeah,
these two triangles, and it makes these two other triangles are equal.
Not equal.
Well, they're congruent.
They're congruent. Equal and congruent are slightly different. So they're congruent. Why is that?
Well, because this point is the midpoint of this line.
Okay. Well, show me why those two triangles are the same. What is your reasoning that this triangle BAM and triangle CAM are the same?
They share one side.
Okay.
These sides are equal.
All right.
And these sides are equal.
Okay, so those two triangles are congruent because
the side lengths are the same.
All three sides are the same. Okay, very good. So those two triangles are congruent.
So that means the corresponding angles are the same.
Okay. Why?
Well, it's the same because you can fold this triangle over to be this triangle.
Okay, so why don't you mark the two angles that are the same now?
So
that angle and that angle are the same.
These two.
And that angle are the same too. Oh, awesome. Okay, anything else the same?
These angles. Well.
Mark it with 3 ticks.
Yeah, they have to be the same.
Okay, mark it. Alright, so great. So we just found that this triangle, BAM and CAM, are the same triangle, and that means those two angles are equal. Sorry, I fell into the trap. They're congruent triangles. They're definitely not the same triangle. They're different triangles. But they're congruent, so those two angles are the same. Next is show that AM, this line coming down here, is actually perpendicular to BC. There's a couple different ways to do this.
Well, that would mean these two would be 90 each.
Right. That's exactly right. That those two angles are both 90 degrees. And we're trying to figure out why that would be the case.
Well, these two angles, I'm just going to call these angles are X, these angles are Y, and these angles are Z.
Okay.
So, 2Z is 180. Because we have a straight line and the line coming down.
Oh, very good. 2Z is 180. Those two angles together make up a straight line. And that's 180 degrees. Good.
So, this means Z is 90.
That all by itself right there means Z equals 90.
It's quick and easy proof.
Quick and easy proof. And different, good job, different from the one we talked about last night. Which is, last night, what I showed you was in the big triangle in ABC, we have this angle plus this angle plus this angle is what? So y plus 2x plus y
is 180.
Is 180. That means 2x plus 2y is 180.
So
or
x plus y
is
90.
Is 90. Why does that help us? Why does that help us say anything about what angle z is?
Well, because the sum of these two angles is 90.
Okay, so this angle plus this angle here is 90.
So that means this angle has to be 90.
How come?
Because angles in a triangle sum up to be 180.
Good. This is the third angle in a triangle, and if the other two angles already add up to 90, that third angle's got to be 90 because the whole triangle's angles add up to 180. So there's a different idea of why z equals 90. Okay, very good. Good job. Does that make sense?
Yep.
Alright, good job, smart enough.